Okay, hello everyone. I think I need to explain all these examples to you, and I would like to provide more alternative answers to these questions. Okay. Okay. Let me write in the next page. Okay. So these functions we can write as x plus 2 minus 3 and x plus 2. And then we can rewrite this as 1 minus 3 x plus 2. Okay. And then we can rewrite these terms. And 1 minus, let's divide by 2. So our goal is, again, we need to have 1 over 1 minus x. So this is x over 2 plus 1. Okay. And then we are going to have 1 minus, let me put 3 over 2 over here, and then 1, and this will be 1 minus x over 2. Okay, I think we have a very clear structures now. So this will be pretty similar to 1 over 1 minus x, right? Okay, next is, let me write here. So 1 minus 3 over 2 sum of negative x over 2 with power of n. Okay. Now if we start with n equals 0, this is what we get. If we are having 0 in terms of, if we plug in 0, we can exchange this into 1 minus 3 over 2 minus 3 over 2 n equal 1, right? So when you apply this 0 here, this will be 1. Okay, so we will have negative half, negative. We are including the 3 over 2 inside, and we will have n equal 1 to infinity. Let me write negative 1 with power of n, and then 3xn, and then over 2 with power of n plus 1 because of this 2. Right? I think that's it. And then we need to find the radius and the interval. So how do we find? So we need to go for geometric. So we have this geometric, right? This as a geoseries, and we could argue that this geoseries will be converges when this is true. So we have, which means r is equal to, and the interval of convergences will be from negative 2 to 2. Okay. Okay, the next question is this functions x over 1 plus 4x, and it's squared. Now we may take the 1 over 1 plus 4x as our considerations, because we can let this becomes this form and we can write down the sum. Okay, and then we also can consider when we have 1 this will become okay, and then we have -4, right? And we can get the value when we differentiate. This will be -4 with power of n, and then the power rule. Okay. Or if we want to make it from n equals 0, we can make it -4 n plus 1, then n plus 1, and then x with power of n. And now we have the functions is x, right? So we are looking at these two different equations. So we need to make this -4 into x. How we are going to do that is we are going to multiply with -x over 4. So when we are multiply this two, we will get into x. Okay. So let's do that. So -x over 4, and we are going to include this sum here inside this sum. And we can write this maybe multiplying the x and separate the -1 with power of n, 4 with power of n, and then n plus 1, and then x n plus 1. Okay. So this will be cancelling with this and this with this. Okay. So we have this is 4 -4x less than 1. This is from the geometric here. Okay, so we can make a conclusion. Actually, you can make conclusion from here that you can take this as r is actually 1 over 4. Let me just write down here, and then the interval will be going to be, no, I think the interval is not really needed. We just need to calculate the radius of convergence. Okay, the next one is here. Okay, I hope you get the idea. Okay. Okay, if you remember that we have 1 over 1 minus x squared, this is we get from the derivative of our 1 over 1 minus x, right? And then we are getting the sum as n plus 1 and x, or if you want to write in more from 1 like that, you can have this is n This is x and minus 1, but I would like to write in terms of n equals 0. Okay. Okay, if we derive this one more time, okay, so we derive one more. This will result into 1 minus x cubed. And we derive this d dx. This is equal to the sum. Let's just write 1 because I will multiply with n plus 1, and then x, n minus 1. Okay. And now we have the f of x is x squared plus x divided by 1 minus x cubed. Okay. Now what we have here is 2 over 1 minus x cubed. Okay. Now we would like to incorporate this form inside this functions. So first maybe we can separate these functions. And each one we need to multiply with something. Okay. So maybe we need to multiply with this one, should be incorporate 2. So we need to have 2 like that. And then divide by 2. Okay. So we are going to exchange this later on with the sum. And do the same thing with this one. X over 2, 2. We are going to change this into the sum. Okay. Now we can write this in terms of sum. We are going to incorporate this sum. So n equal 1. This is n plus 1, x n minus 1, and plus x over 2. Okay, so let's multiply. So x will multiply with x will multiply with x, and we will have maybe we'll write n plus 1, n, x, n plus 1 over 2, and then plus okay, now to combine both of this, if you look closely, then we will have this is n plus 1, this is n, right? Let me reduce the left part and becoming x with power of n. So let's start by n equal 2. So to make it true, then we need to have n minus 1 and n, right? So it should be still true, and this will be x with power of n. Okay. And then this part will be still this. Okay. Now next is we are going to combine both of this, but to combine this we need to make sure that this n equal 1 becomes 2 also, right? So let's do that. So write the same sum, maybe just n squared minus n over 2 x to the power of n. Okay. And then to make it 2, we can take this n equal 1, and then we can input all the n. So we will get 2 multiplied by x power of n divided by 2, which is just x equal n. So we can plus x equal n and then plus. In which we can solve this. We can solve, sorry, this is not n, this is just x. So we have x plus, okay, this part will be cancelling with this. So we are only having the sum. Or if we look on these terms here, this is, we can actually forming back to just n squared x to the power of n. And the radius is just 1. Okay. Okay. Now, I hope you get the idea. Okay, it's a little bit takes time to process the sum and solving the algebra for the summations. Okay. But I hope you get familiar with the sum. Okay. Now looking at the ln. The ln, if we think on the perspective derivative, we can think this as a negative integrations of the x. This is 5 minus x, in which we can have 1 over 5 and then differentiate. Okay, we can think from this point of view, and then we can use these informations to make out our sum. Okay, so we will have sum of x over 5 with power of n dx. So of course we can try to deal with the integrations. So we will have xn, or let me write a constant, minus 1 over 5. So xn plus 5, this is 5 over n, and also n plus 1. Or we can simplify it, become okay. Now we can check the c, the constant. We check if we put x equals 0, we get c will be equal to ln 5, which means that this will be ln 5. So the series converges for this geometric one. So converge when the x over 5 is less than 1. So the radius is 5. Okay. I hope this additional content can help you to practice and utilize some basic knowledge on the representation of power series okay? Especially to solve some derivative or integral within the power series. Okay.